When building software, duplicating methods across different objects not only consumes more memory, but also goes against the DRY principle. DRY stands for don't repeat yourself. Let's consider how we can use inheritance to share common functionality in a way that aligns with best practices. Imagine we have multiple types of programmer objects, such as front-end programmer and back-end programmer, and they share some common behaviors. Instead of duplicating methods across both constructors, we can define a generic programmer object that contains shared methods. So let's define a base shape for our shared methods, and we name it programmer. Now this will accept one parameter, which will be name. So we can set this property for the name, and we can define all of the shared methods that we want. So we can do this.code, assigning this to anonymous function, and here we log out, this.name, starts coding. Then we can define this.debug. Let's extend this so we can see it more easily. Function. And here we log out. This.name is debugging. And our last method, this.meeting, we log it out. This.name is attending meetings. So here, let's create two instances of this. So we can say Alice, we call a new programmer to call this constructor function, pass in the name, and let's duplicate it. So Shift Option and down arrow. I'll pass in Steven. So now, let's do alice.code and steven.code. Here, we save this, and we see the expected console log statements. So when you define methods directly within the programmer constructor function, each instance of programmer will have its own copy of these methods. So here, the instance of Alice will have its own methods for code, debug, and meeting, as well as the instance for Steven. This approach is less efficient in terms of memory usage because every instance has duplicate methods. So remember, functions are objects in JavaScript. So let's compare the code functions for these two programmer objects. So here, I'll comment this out, and then I'll log out, alice.code, so that reference, and we'll see if this is strictly equal to steven.code. So we are comparing to see whether these functions reference the same object. So we see the value of false. So in this case, Alice and Steven each have their own copies of the code, debug, and meetings method, which is redundant and can consume more memory, especially if you create many instances. So here, we can clear this out. I'm going to expand this. So instead of defining these three methods in the constructor function, we can define it in the prototype so that these methods will be shared. I can define it here, do programmer.prototype.code, and then I can assign the function here. And I'll do the same with the other methods. So programmer.prototype.debug, we'll copy this and paste it there. Now we have one more for the meetings, programmer.prototype.meetings, and then we will copy the implementation here. Now since we defined on the prototype, we can remove this. So now when we compare these functions, so alice.code and steven.code, we saw the output of true because they are referencing the same function on the prototype. So these functions are shared amongst all instances. So when you define methods on the programmer.prototype, all instances of programmer share the same method implementation. So this is more memory efficient because the methods are not duplicated for each instance. Instead, they are shared among all instances, which is the essence of prototypical inheritance in JavaScript. In this case, Alice and Steven share the same code, debug, and meetings method, which are defined on the prototype. This reduces memory usage and ensures that all instances benefit from any updates to these methods without needing to update each instance individually. What are the benefits of defining methods on the prototype of a constructor function in JavaScript? And how does this approach align with the DRY principle? Defining methods on the prototype of a constructor function in JavaScript provides two main benefits. The first being memory efficiency. Methods defined on the prototype are shared among all instances of the constructor. This reduces memory usage since each instance does not create its own copy of the method. The second benefit is code reuse. By using the prototype, you avoid duplicating code across multiple instances, aligning with the dry principle. This makes the code easier to maintain and update. In summary, prototypical inheritance allows for shared behavior and memory efficiency, making your code more maintainable and performant. So let's summarize what we covered so far. We implemented methods on the prototype for three reasons. One is memory efficiency. So defining methods on the prototype ensures that all instances share the same method implementations, reducing memory usage. The second benefit is method sharing. So prototype methods are shared among all instances, making it easier to maintain and update the methods. And the third is the benefit of inheritance. Prototypical inheritance leverages this shared behavior, allowing derived objects, like front-end programmer and back-end programmer, to inherit and use these methods without duplication. By defining methods on the prototype, you adhere to the principle of efficient memory usage and code reuse, making your JavaScript code more maintainable and performant. Now let's define more specific programmer roles. You can expand this. Scrolling up, we can create a front-end programmer constructor function. So this also takes in a name. And we'll create our constructor function for a back-end programmer. Now we want to call the programmer constructor function to initialize the name property. So we want this version, front-end programmer and back-end programmer, to be derived objects that inherit from the programmer constructor function. So in order to call the programmer constructor function, we'll do programmer.call. Now, for the first argument, we will pass the current context, so we use the this keyword. So this references this current object, meaning the instance of the front-end programmer. Now, for the second argument, we will pass a name, because that is the expected parameter for the programmer constructor function. So here when we scroll up, this constructor function expects a name. So we can also repeat this for the backend programmer. So using programmer.call, we are calling the programmer constructor function and setting the context to the new instance of the front-end programmer or back-end programmer. This ensures that the name property is correctly initialized for each specific programmer type. So, for setting up the inheritance, to enable the front-end programmer and back-end programmer to inherit the methods from the programmer prototype, we need to set their prototypes to be instances of the programmer constructor function. So to do that, we can do front-end programmer.prototype. This is assigned to object.create programmer.prototype. Now we repeat this, so shift option down arrow for the backend programmer. I'll also set the constructor, so front-end programmer.prototype.constructor, and set this to front-end programmer, and we'll repeat that for the back-end programmer. So now front-end programmer and back-end programmer instances can use the methods defined in programmer, so as access to code, debug, and the meeting method. So let's actually see this. Here I will set this here. We'll clear it out. Let's comment out this console log statement, and we'll utilize these two instances. We can do const, say Joe is new front-end programmer, the name of Joe. So here we can say joe.code, joe.debug, and joe.meeting. And we see the expected console log statements defined on the programmer prototype. Now let's create an instance of the backend programmer. So I can say const, and I'll say gen, new backend programmer, gen. So we'll call the same methods, gen.code, move this up, gen.debug, and gen.meeting. And here we see the expected console log statements. So this setup uses prototypical inheritance to share common methods among different types of programmers, minimizing redundancy and enhancing maintainability. By structuring objects in this way, you effectively utilize JavaScript's dynamic nature and prototypical inheritance to create more efficient and organized code. This approach ensures that all specific programmer types benefit from updates to the programmer prototype without needing to modify each constructor separately, adhering to efficient coding practices and the principles of object-oriented design. How does using programmer.call, passing in for the first argument the this keyword, and for the second argument passing in the name, within the constructors of front-end programmer and back-end programmer, ensure proper initialization of the name property for these specific programmer types? Using programmer.call within the constructors of front-end programmer and back-end programmer ensures proper initialization of the name property by calling the programmer constructor with the current instance, the this keyword. So this way, the name property is correctly set for each front-end programmer and back-end programmer instance, just like it would be for a programmer instance. Why do we use object.create and pass in for the argument programmer.prototype to set the prototypes of front-end programmer and back-end programmer? And what is the significance of resetting their constructor properties? We use object.create to set the prototypes of front-end programmer and back-end programmer so they can inherit methods from programmer. This allows instances of these objects to share the same methods, making the code more efficient. Resetting their constructor properties ensures that instances are correctly identified as front-end programmer or back-end programmer, maintaining proper type identification. So recap and core concepts. The term prototype in JavaScript essentially means the parent object. In our constructor functions, we define properties and methods. Often we define a general constructor function, like programmer, which contains common properties and methods. So in this case, the name property and the code method. However, we may need to create more specialized objects, such as front-end programmer, which has specific capabilities. Instead of duplicating the properties and methods defined in programmer, we use prototypical inheritance, also called prototypal inheritance, to reduce code duplication. By doing this, front-end programmer, so this, will inherit the properties and methods from the programmer parent object. When we call a method, such as this code method, JavaScript checks the front-end programmer object. If it doesn't find the method definition, it looks up the inheritance chain to the programmer prototype and uses the method defined there. This setup means we write less code, which is easier to maintain and modify because the code is defined in one place and reuse. As applications grow, reducing code duplication through inheritance makes logical sense. So addressing constructor property issues in prototypical inheritance. When implementing inheritance, a common issue is the constructor property. This property is important for creating instances dynamically based on the constructor function associated with a prototype. So let's illustrate this with our programmer example. Here we have the parent object, or the base object, and we have the derived object, the front-end programmer, which is a more specialized version of the programmer base. By using programmer.call, we inherit the name property, but we also want to inherit its methods. So to do this, we would do front-end programmer.prototype assigned to object.create programmer.prototype. Right, so add a comment here. So this is setting up inheritance. So we inherit methods. So every object has a constructor property, which refers to the function called to initialize the object. When we call new front-end programmer, so here when we are creating an instance of front-end programmer, we wanted to call the front-end programmer constructor. This refers to this constructor function. However, after setting the prototype to object.create and passing in programmer.prototype, as we did here, to inherit the methods, the constructor property of front-end programmer.prototype points to the programmer constructor function. So it's pointing to this constructor function as opposed to this one. So this can cause confusion. So to demonstrate this, you can log it out, say front-end programmer.prototype.constructor, and strictly equal to this constructor function. just to demonstrate that it is now referencing this constructor function rather than the front-end programmer constructor function that we want it to. So, we can resize this so we can see the output in our console, and I'll save it. And here we see the value true. So this shows that it's referencing this constructor function. So to correct this, we reset the constructor property after changing the prototype. Right, so after we inherit the methods, then we need to make sure that we're referencing the correct constructor function. So to do this, we would do front-end programmer.prototype.constructor, and we assign this to the front-end programmer constructor function. So now, here when we log this out, if we save this again, we see the value is false, because the front-end programmer constructor function is no longer referencing the programmer constructor function. So to recap, whenever you change the prototype of a function in JavaScript, reset the constructor property. This ensures the constructor property accurately reflects the actual constructor function for instances, preventing potential issues in object creation and inheritance. This practice maintains consistency and predictability, especially in complex inheritance hierarchies. What is the primary benefit of using prototypical inheritance in JavaScript when creating specialized objects like front-end programmer from a general constructor function like programmer? The primary benefit of using prototypical inheritance in JavaScript is that it reduces code duplication. By inheriting properties and methods from a general constructor function like programmer, specialized objects like front-end programmer can use those shared features without having to rewrite them. This makes the code easier to maintain and update since the common code is defined in one place and reused across different objects. Why is it necessary to reset the constructor property when setting up inheritance using object.create in JavaScript? And what potential issues can arise if this step is omitted? It is necessary to reset the constructor property when setting up inheritance using object.create in JavaScript because object.create changes the prototype, which can mistakenly point to the wrong constructor. If you don't reset it, the constructor property might refer to the parent object, like programmer, instead of the child object, like front-end programmer. This can cause confusion and bugs when creating new instances, as JavaScript won't know the correct function to use for initializing the objects. How does JavaScript handle method lookups in the context of prototypical inheritance, and what is the sequence of steps when a method like code is called on an instance of front-end programmer? When a method like code is called on an instance of front-end programmer, JavaScript follows these steps. The first is checking the instance. JavaScript first looks for the code method directly on the front-end programmer instance. Second, check the prototype. If it doesn't find the code method on the instance, it looks up the prototype chain to the front-end programmer.prototype. Next, it checks the parent prototype. If the code method isn't there, it continues up the chain to programmer.prototype, where it finds and uses the code method defined there. This process ensures that the instance can use methods defined in its own class or any parent class, following the inheritance chain. So in object-oriented programming in JavaScript, constructors play a crucial role in setting up new objects. So constructor functions essentially refer to the function that is called or invoked to instantiate an object with a given state. So we will modify the programmer constructor that we've been working on. So we can do function, we can call it programmer, and we'll specify two parameters, so the name and the specialization. And we can set that here with this keyword and this.specialization assigned to specialization. So now let's create a derived constructor function. So this will be a more specific type of programmer, which we will call a front-end programmer, who will also have a preferred framework along with a name and specialization. So we have function, front-end programmer, name, specialization, and preferred framework. So, to inherit the name and specialization properties from this parent object, rather than having to duplicate that code, we do programmer.call. For the first argument, we'll pass in the this keyword. So that refers to this current object. And then we'll pass in name and specialization, because these are the two arguments needed, because these are the two parameter variables defined in this programmer constructor function. So now that we've inherited those two properties, we need to assign our preferred framework. Now that we implemented that, let's create an instance of front-end programmer. We can say const, say Steven, new front-end programmer, Steven for the name. The specialization will be front-end, and the preferred framework, we'll specify that to be React. So React is actually a JavaScript library, but in this context, we will consider it a framework. So let's talk a bit about the new keyword. When you use the new operator, several things happen. First is a new object creation. So JavaScript creates a new object in memory. Second is setting the prototype. It sets the prototype of this new object to the prototype of the constructor function from which it was called. So it would be programmer.prototype if you were to do new programmer, and it is front-end programmer.prototype for when you do new front-end programmer. So third is executing the constructor. The constructor function is called with the this keyword bound to the newly created object, allowing properties and methods to be assigned to this. And fourth is returning the object. Unless the constructor explicitly returns a different object, the new object is returned by default. So let's discuss the this keyword. So in the context of a constructor function called with the new operator, by default, the this keyword refers to the new object being created. And second, if the constructor function is called without the new operator, then it would refer to the global object. So this would be the window object in browsers or the global object in Node.js, which can lead to unexpected behaviors and errors. Show an example of this. Here we log out. The front-end programmer name. Now to shift option down arrow to create those copies, the specialization, and the preferred framework. Let's resize this so we can see our output in the console. Then clear this out. And when we save it, we get our expected output logging our properties. So the key takeaway, using constructor functions properly with the new operator ensures that the new objects are set up correctly with their intended prototypes and properties. It is essential to use the new operator to avoid unintended side effects and ensure that the this keyword behaves as expected within the constructor function. This mechanism is fundamental for implementing inheritance and creating a hierarchy of objects in JavaScript. Explain the steps involved when the new operator is used with a constructor function in JavaScript. Why is it important to use the new operator when calling a constructor function? When the new operator is used with a constructor function in JavaScript, the following steps occur. First is a new object creation. So, a new JavaScript object is created in memory. Second is setting the prototype. The new object's prototype is set to the constructor function's prototype. Third is executing the constructor. The constructor function is called with the this keyword bound to the new object, allowing properties and methods to be assigned to it. And the fourth step is returning the object. The new object is returned automatically unless the constructor explicitly returns a different object. It's important to use the new operator to ensure that the this keyword refers to the new object being created. Without the new operator, then the this keyword will refer to the global object or be undefined if you were using strict mode, leading to unexpected behaviors and errors. So refactoring with the programmer function. So suppose we have a base programmer class and specific subclasses like front-end programmer and back-end programmer. So here's how you can set up inheritance using a generalized extend function. So we have our base programmer constructor function and a method. Now let's create our specific programmer types. So that's function, front-end programmer with the name. We call programmer.call, this, and name. So let's copy this and we'll create our back-end programmer. So let's define an extend function that automates the process of setting up prototypical inheritance between a parent and a child constructor function. So we can inherit the methods and properly assign the constructor function. So we can do function extend. So for the first parameter variable, I'll specify that to be the child object or child class. And the second will be the parent. So we want to inherit the methods of the parent. So we do child.prototype is assigned to object.create parent.prototype. So then we will assign the constructor prototype.constructor to the child. So now using the extend function. So with this extend function implemented, you can easily set up inheritance for any number of specific programmer types by simply calling it. So we'll just do extend front-end programmer and programmer. So I'll do shift option and down arrow, and I'll pass in back-end programmer. So now let's test the implementation. I'll resize this so we can see it in our console. So we'll create instances of the front-end programmer. So let's say const Steven, assigned to new front-end programmer. And I'll do shift option and down arrow, and I'll just change this to be back-end programmer with the name of Alice. So now we can call and invoke the method that we inherited, which is the code method here. So it is defined on the parent object, which is programmer. So we can do Steven.code, and we could do Alice.code. And here when we save it, we get the expected output. So the benefits of using the extend function, the first is encapsulation. So by encapsulating the inheritance logic in the extend function, we avoid redundancy and make the code more maintainable. And second is reusability. The extend function can be reused across the project wherever inheritance is needed, promoting consistency and reducing the chance of errors. This approach not only streamlines the inheritance process, but also makes the codebase more organized and easier to manage. By using a generalized method for extending prototypes, you ensure that all derived classes correctly inherit from their parent class without manually setting the prototype and constructor each time. What are the benefits of using a generalized extend function to set up prototypical inheritance in JavaScript? Explain how it improves encapsulation and reusability in your code. Using a generalized extend function to set up prototypical inheritance in JavaScript has several benefits, one being encapsulation. The extend function wraps the inheritance logic in one place, so you don't have to repeat the same code for every new child constructor. This makes your code cleaner and easier to maintain. And the second benefit is reusability. Once you have the extend function, you can use it whenever you need to set up inheritance, saving time and reducing the chances of mistakes. This ensures consistency across your codebase. Overall, it makes your code more organized and easier to manage. To demonstrate method overriding, we'll redefine the code method in front-end programmer to include additional behavior specific to front-end programming. So currently, we have this derived object, the front-end programmer, which inherits the properties and methods from the base programmer object. So when we call or invoke the code method, it simply calls the function derived in its parent. But we can override this functionality. So here, before I instantiate it, I will scroll up. So I'll resize this. Then before instantiating it, so I can say frontend programmer.prototype.code and assign this to an anonymous function. So I'll say programmer, so that constructor function for the parent.prototype.code.call, and then I'll pass this keyword. So this calls the base implementation defined up here. Now I can say log, and I'll do backticks. This dot name is coding in HTML, CSS, and JavaScript. So now I will save this, and we're invoking the code method on the front-end programmer. We can save it. Let's restart the live server. So Command Shift and P, live server open. Let's resize this. All right, I'll close this one out. Open up the developer tools, so Command Shift and J. So now I close the sidebar with Command V or Control V, and I get the expected output. I get Steven starts coding, which is the output defined in the programmer implementation of the code method. And in this derived object, where we did method overriding, I also log out. Steven is coding in HTML, CSS, and JavaScript. So an explanation of method overriding. This setup showcases how a prototypical inheritance works in JavaScript. When you call the code method on an instance of front-end programmer, JavaScript first checks the front-end programmer prototype for this method. Since we've overwritten code in front-end programmer, this version is executed, which also calls the base class method to maintain the general programming behavior, then add specific behavior. So if I were to comment this out, it would simply override it and simply log out what we define here. Right, so just this expected output. So some key points. The first is method lookup. JavaScript's prototype chain means that method lookup starts with the object itself and moves up the chain until it finds the method or reaches the top of the chain. And second, using the call method for base methods. To include the base class method's functionality when overriding methods, use call to specify the context, passing in the this keyword, and ensure the base method executes correctly for the derived class instance. By following these principles, you can effectively manage and extend behaviors in JavaScript, allowing for more flexible and reusable code structures. How do you override the code method in front-end programmer to include additional behavior while still calling the base class method? To override the code method in front-end programmer and include additional behavior while still calling the base class method, you could do the following. First, you would define the new code method on front-end programmer.prototype. Inside this method, you call the base code method using programmer.prototype.code.call and passing in the this keyword, and this will keep the original behavior. And then you would add the new behavior specific to front-end programmer. This way, when code is called on a front-end programmer instance, it will first run the base code method and then add the new behavior. What is the significance of using call when invoking the base class method in an overridden method in JavaScript? Using call when invoking the base class method in an overridden method is important because it ensures the base method runs in the correct context. By using call, you pass the current object, which would be the this keyword, to the base method, so it behaves as if it was called directly on that object. This allows the base method to properly access and modify the object's properties. Polymorphism is a key concept in object-oriented programming. So polymorphism stands for many forms, and it is what allows objects of different classes to be treated as objects of a common superclass through inheritance. It's essentially the ability for different objects to respond to the same method call in different ways. First, let's look over this starting code that we're using. We have the extend method, which is a utility function that we are using so that a child object can inherit methods from parent object and make sure that we are resetting the constructor. We have a base object for our programmer, which just sets a name property, and we define a method named work, which simply logs out a string. Then we have two derived objects, front-end programmer and back-end programmer. So both of them inherit the name property from this base programmer object. And we are calling the extend method. So we are inheriting the work method. So now we have this boilerplate code. Let me resize there. So implementing polymorphism. We have our specialized programmer types, which is front-end programmer and back-end programmer. We want each of them to have a unique implementation of the work method. Before instantiating an instance of front-end programmer, we could do front-end programmer.prototype.work and assign this to an anonymous function. So we are overriding this method. We could do log, and we'll do backtick, is designing and coding the front end. We have implemented that method overriding implementation. Now we can do backend programmer.prototype.work, assign this to an anonymous function, and we will log it out. Backticks, we can say this.name is developing server-side logic. All right, let's create a backend programmer. So I'll scroll up and I'll do Shift Option and down arrow, and I'll just name this to be Alice, and backend programmer. So we've instantiated two instances, so one for the front-end programmer and one for the back-end programmer. So using polymorphism. So let's create an array of programmer objects, which can be either a front-end programmer or back-end programmer. So since we are utilizing inheritance, we know that a front-end programmer is a programmer and back-end programmer is a programmer. Right, so the concept of is very important, such that our inheritance makes logical sense. So by creating this array, we'll say programmers. This will demonstrate how each object can use the work method differently, according to their specialized class definition. So, create an array, and first I'll pass in Steven, so that front-end programmer, and Alice, the back-end programmer. So now let's iterate through this programmer's array. I can do that with a for of loop. So I'll say for let programmer of programmers, and then we'll call programmer.work. And so now I will call its unique implementation of the work method. So the front-end programmer will call this method, and the back-end programmer will call its own implementation of the work method. So now let's save this and we'll see the output in the console. So now on the right, we see Steven is designing and coding the front end, and for the back-end programmer, Alice is developing server-side logic. So some key points. The first is no type checking is needed. So with polymorphism, you don't need to check the type of each object before calling the work method. Each object knows its own implementation of the work method, allowing them to behave correctly according to their specific type. And the second is code flexibility and reusability. Polymorphism simplifies code management and enhances its reusability by allowing you to use a general interface for a range of different objects. This example demonstrates how polymorphism can be leveraged in JavaScript to interact with objects from different classes through a common interface, enabling flexible and easily manageable code. This approach is particularly useful in systems where new types might be added, but existing code shouldn't need extensive changes to accommodate them. How does polymorphism allow different objects to respond to the same method call in different ways? Polymorphism allows different objects to respond to the same method call in different ways by using method overloading. Each object, even if they are of different classes, can have its own version of a method. So when a method is called, the correct version for that specific object is executed. What are the benefits of using polymorphism in terms of code flexibility and reusability, as demonstrated by the programmer example? Polymorphism increases code flexibility and reusability by allowing objects of different types to be treated through a common interface. In the programmer example, it means that you can call the same method, in this case it is the work method, on any programmer object without worrying about its specific type, making the code simpler and easier to extend with new types of programmers. Understanding inheritance in composition with the programmer function. While inheritance is a powerful feature in object-oriented programming, it's important to use it carefully to avoid creating overly complex and fragile systems. So potential issues with inheritance. Inheritance should always satisfy the is-a relationship, meaning that a subclass should represent a more specific version of the superclass. For instance, a front-end programmer, which is the subclass or derived class, is a specific type of programmer, with programmer being the superclass or base class. However, problems can arise if the subclass inherits methods that do not logically apply to it, leading to an inappropriate relationship. Example of inheritance complexity. So consider a scenario where you are expanding the programmer function to include different types of technical staff in a company. So I can resize this. I implement a base object. So this will be an employee object, which has a name parameter, this.name, and we'll set the name value. Now we can create a more specific version of an employee. So this subclass will be programmer. So it takes in a name, and we call employee.call, then the this context for the first argument, referring to this programmer object, and the name. So this now inherits the name property. If we can create another subclass or derived object, and this would be a manager. So this will also inherit from the employee base object. So a programmer is an employee and a manager is an employee. So it satisfies the is a relationship. So I can call employee.call this and the name. So manager inherits from employee. Now if the employee had programming methods, those methods will not logically apply to a manager object. So this example shows that the inheritance hierarchy can become inappropriate and bothersome, as you don't want to inherit methods that don't make logical sense. So this would happen in the case if this.employee had a method like code, and then we'll log out, write code. So it wouldn't make logical sense for a manager to have that functionality. We'll clear that. So as a best practice, you want to limit the inheritance depth. In general, it's best to keep inheritance hierarchies shallow, ideally not going beyond one level. Deep inheritance trees can become difficult to manage and understand, favoring composition over inheritance. An alternative to inheritance is composition, where you build classes out of components rather than using a strict parent-child relationship. This approach often provides greater flexibility and reduces dependencies between classes. When you think of the term composition, imagine it as a has-a relationship, whereas inheritance represents an is-a relationship. With composition, an object includes instances of other objects and their functionality, allowing it to have the behavior it needs without relying on hierarchical structure. Implementing composition with mixins. In JavaScript, composition can be achieved using mixins, where functionality can be mixed into a class. For example, instead of having a programmer inherit all behaviors, specific functionalities like can code, can review, can design might be mixed in as needed. So, const can code, which would be a JavaScript object literal, and within it, we can have a method for coding. So I'll say log, and I'll say this.name is coding. I can define another object, say can review, and it will define a review method, so log, and I can say this.name is reviewing code. So now, let's actually move this up. So I move it up with Shift and the up arrow. So I'll just reorder that. So we have these objects defined before the implementation of our programmer constructor function. So let's create an instance of a programmer. So I'll say const Steven equals new programmer. Just pass in my name. So now, for this programmer constructor function, to utilize the code method and review method, we can do object.assign this as the first argument, and we'll pass in can code and can review. So I can add a comment here. Scroll up and I'll say composing the object with necessary functionalities. So now let's create an instance of programmer. So I can say const Steven equals new programmer. I'll pass in my name. So then I can do Steven.code and Steven.review. I can save that, and I get the expected output. So in summary, in software design, while inheritance might seem like a straightforward way to reuse code, it's essential to evaluate whether it introduces unnecessary complexity. Often composition provides a more flexible and robust alternative, allowing objects to be constructed from discrete, reusable behaviors. This approach aligns with the principle of favoring composition over inheritance, helping to maintain clean and manageable code bases. What is composition? Composition is a design principle where an object is made up of one or more other objects, allowing it to use their functionality. It represents a has-a relationship, meaning that an object contains and uses other objects rather than inheriting from a parent class. What are potential issues with inheritance, and why is it important to ensure that a subclass satisfies the is a relationship with its superclass. Potential issues with inheritance include creating complex and fragile systems if subclasses inherit methods that don't logically apply to them. It's important to ensure that a subclass satisfies the is a relationship with its superclass to maintain logical consistency. For example, a front-end programmer should be a specific type of programmer. How does composition offer a more flexible alternative to inheritance in software design, and how can it be implemented in JavaScript using Mixins? Composition offers more flexibility than inheritance by allowing objects to include and use functionality from other objects, avoiding complex hierarchies. In JavaScript, it could be implemented using Mixins, where specific functionalities are added to an object as needed. This way you can add functionality without relying on inheritance. What is a Mixin? A Mixin is a reusable piece of code that adds specific functionality to objects or classes. In JavaScript, Mixins are used to share behavior across multiple objects by copying properties and methods into them. In JavaScript, object.assign is a powerful method used to copy properties from source objects to a target object. This capability is particularly useful for implementing Mixins, where common functionalities can be shared across different objects without forming a rigid inheritance structure. Here's how you can apply this to a programmer function, allowing programmers to have modular capabilities like eating, walking, and coding. So defining Mixin objects. First, let's define simple objects that contain methods which can be mixed into any target object. So we can implement a canEat method, and within it has an eat method. Set this to an anonymous function. So I can say this.hunger is decreased, and I can log, use backticks, this.name is eating. So end that with a semicolon. Now I'll implement two other objects. So the next will be canWalk. Then we'll have a walk method. So I'll say a function, and we will log it out. I'll say this.name is walking. We'll end that with a semicolon. And then we have canCode. So we can have a method coding, and we will log out this.name is coding. We end that with a semicolon. And I'll just add a period here just to be consistent with the other strings that we're outputting. So using object.assign to mix capabilities. You can use object.assign to add these capabilities to a programmer. So if I scroll up, I'll define a constructor function for a programmer. This takes in a name parameter variable. So we set the name, and we'll set a property for the hunger. So this will be the default hunger level. So now we have the Mixin functionalities into the programmer's prototype. So you can do object.assign programmer.prototype. So this would be the target, and the source objects that we want to copy will be canEat, canWalk, and canCode. So now we can instantiate a programmer. So I'll say const programmer, and then new programmer, passing in my name. Then I can call each of these methods. So first, let's just log this out. I can log programmer. Let's resize this so we can see it in the console, and I'll save it. So here when we expand, we see the property for hunger and the name. Right, so our expected properties. So now let's call programmer.eat, and then I'll do shift option down arrow just to make copies of this. And then I'll say walk, and then I'll say code. Save that. And here I get the expected outputs. So Steven's eating, Steven is walking, and Steven is coding. So to create a reusable Mixin function, To streamline the process of mixing capabilities into different objects, you can create a reusable mixin function. So let's define that just at the top. So I can say function, and I'll name it mixin. Now for the parameters, we'll specify a target object, and we will use the rest operator with 3 dots, sources. So we can pass in one or more values as an argument. So we'll utilize object.assign the target, and then we will spread the sources. Alright, so now when we use this, rather than doing object.assign, let's expand this so we can see it better. So now I can comment this out, and we utilize our mixin function. So here, I can say mixin, so the target is programmer, and we can pass in a variable number of arguments. So I'll say can eat, can walk, and can code. So let's resize this. And when I save it, I get the same expected output. So this approach demonstrates the flexibility of composition over inheritance. By composing objects from smaller function-focused objects, you can easily extend functionality without the constraints of a strict class hierarchy. This method not only makes your code more reusable, but also makes it modular and easier to understand. Using mixins with object.assign allows for dynamic capabilities to be added to objects, promoting code reuse and reducing the complexity typically associated with deep inheritance hierarchies. This method aligns well with the modern JavaScript best practice of favoring composition over inheritance, providing greater flexibility and easier maintenance. How does using object.assign facilitate the implementation of mixins in JavaScript, and what are the benefits of this approach compared to traditional inheritance? Using object.assign in JavaScript makes it easy to implement mixins by copying properties from multiple source objects to a target object, adding new capabilities without using inheritance. This approach offers greater flexibility, avoids complex inheritance hierarchies, and promotes code reuse by allowing you to combine only the needed functionalities. This section delved into several advanced topics essential for mastering object-oriented programming in JavaScript. We covered creating your own prototypical inheritance, so we explored how to establish custom inheritance chains using JavaScript's prototype-based inheritance system. We covered resetting the constructor. The importance of properly resetting the constructor property when modifying an object's prototype was emphasized to maintain proper linkages. We covered calling the superconstructor, so techniques for invoking a superclass constructor within a subclass were discussed to ensure that inherited properties were correctly initialized. We covered intermediate function inheritance. We examined how to implement inheritance through intermediary functions, enhancing flexibility in how inheritance is applied. We covered method overriding. The course covered strategies for overriding methods in subclasses to tailor or enhance functionality derived from a superclass. We covered polymorphism. We discussed how polymorphism allows objects of different classes to be treated as objects of a common superclass, facilitating flexible and dynamic code. We covered when to use inheritance. Guidelines were provided on appropriate scenarios for using inheritance, focusing on maintaining a clear is-a relationship. And we covered mixins. The use of mixins was introduced as a flexible alternative to inheritance for composing objects with multiple behaviors or capabilities without forming rigid hierarchical structures. By understanding and applying these advanced concepts, you can write more robust, maintainable, and scalable JavaScript applications. This knowledge will enable you to leverage the full power of object-oriented programming in JavaScript, adapting to various programming challenges with effective solutions.